This assignment is related to topic circular motion. The first part of the assignment are the MCQs that you will solve, and I will discuss some structure questions. So starting with question 11. From this topic, mostly structure questions are there. Even in the past paper, you will find most of the structure questions rather than MCQ. In question 11, a student wondered whether a small buzzer could be powered using the Earth's magnetic field. So basic idea what student is doing, student is having a buzzer. When he rotate, there will be a change in the magnetic field. And due to change in magnetic field, as you know, due to electromagnetic induction, as electromagnetic induction change in magnetic field induce EMF. So student attach a buzzer to one end of a wire. So he attached a buzzer one end of a wire. He held the other end of a wire and drilled the buzzer in a vertical circle. As you can see, he drilled in the vertical circle. Explain how an EMF was produced between the ends of the wire. So there is a wire. Why there is an EMF induced? So this is related to electromagnetic induction. That when this object, the moving wire, changes the magnetic field or cuts the magnetic flux, that's why it induces EMF. So the moving wire will cut the magnetic field, which will induce electromotive force or EMF. The second part, the radius of the vertical circle was 85 centimeters. The buzzer completed 27 revolutions in 15 seconds. Assume that the speed of the buzzer was constant. Calculate the centripetal force on the buzzer. The mass of the buzzer is 150 grams. For these questions, normally it's a direct formula, but even you're using a direct formula, the important thing is that you convert or use correct units. We have the formula for centripetal force. There are two formulas. We can use mv square over r, or we can use mr omega square. These are the two formulas which can be used, where omega is the angular speed, r is the radius, and m is the mass. So we have the mass, but that mass is in gram. We have to convert into kilogram. So divide by 1000.15. R is the radius. So that is 85 centimeter, but we have to convert into meters, so 0.85. And what is omega? Omega is theta divided by t. And this should always be in radian per second. Theta, it can be complete 27 revolution. In one revolution, there is 2 pi radian. So in 27 revolution, it will be 27 into 2 pi. Divided by the total time, how much time it took? It took 15. So this will give us the value of omega. Omega is equals to 2 pi into 27. Why 27? Because there are 27 revolutions. That's why we multiply by 27 and divided by 15. So we can just substitute the value of the omega, that is 27 into 2 pi divided by 15, and the value of the pi is 3.14, and that is omega square. So this will be square. When we substitute all the values, it will give us 16.3 Newton is the centripetal force which is experienced by this buzzer. So important thing is the unit conversion. As you can see, we convert the radius from centimeter into SI unit of meter, and the mass, which is in gram, we convert into kilogram. Is it clear, this part? The next part, the tension in the wire is changing as varied, as you can see. as the buzzer is moving around. Sketch the graph to show the variation in the magnitude of a tension during one revolution. And like one complete revolution is there, and your sketch should calculate the maximum and the minimum value of the tension and add them in your sketch. So first, how we can work out the maximum and the minimum values, as it is, we calculated the centripetal force, so the centripetal force should be 16.3. So all the positions, the resultant should be 16.3. So here the resultant should be 16.3, 16.3, 16.3, 16. So 16.3 is the resultant. But in this case, when it is at position P, the weight is also acting downward. And what is weight? Weight is mass multiplied by gravity. And the mass is given in the question, that is 150 gram, which is 0.15 kilogram. So 0.15, and the value of the gravity, that is 9.81. So 0.15 into 9.81. This will be 1.47. So weight is equals to 1.47 Newton. So we want the result to, all the position, we want result to be 16.3. But out of 16.3 at this position, the centripetal force, all the position we want centripetal force 16.3 Newtons. But out of 16.3, the tension, which is the weight which is acting downward, is 1.47. So if the weight is 1.47, how much the tension we should apply? So it will be 16.3 minus 1.47, which is equals to 14.8 or 83. So the tension at this point will be 14.83 at this point. But at point R, at position R, the weight is acting downward. So weight is 1.47. But we want the resultant to be 16.3. And at this point R, when we check point R, the weight is acting downward, the tension should be upward. So the result T minus W will be equal to centripetal force. And at this point P, the weight is acting downward, the tension also acting downward. So the resultant, the centripetal force, will be equal to W plus T. Centripetal force is 16.3 for position P, and the weight is 1.47. So we work out tension. The tension at this point will be 14.8 at position P. But at position R, tension is acting upward, weight is acting downward, so resultant will be centripetal force, or tension is equals to centripetal force plus the weight. So centripetal force is 16.3 plus the weight is 1.47. So 16.3 plus 1.47, that will give us 17.7. So tension here, which we have to apply, is 17.7. So 17.7 is a tension. But in this position, it was 14.8. And all the other position, it should be 16.3. So when we sketch our result, at P, we need smaller tension. At R, we need the maximum tension. And at Q and S, we'll need the same tension. So if we have the scale, like the values, as you can see, we have 17.7, we have 16.3, and 14.8. So say this is 14. Like if we start our scale, say 13 is there, then 14, 15, 16, 17, and 18. So at position P, we need about 14.8. So we need about 14.8. So it will be somewhat here. At Q, we need 16.3. So 16.3 somewhat here. At R, we need the maximum, which is 17.7. So it will be here. At S, we need again 16.3. So it will be here. At P, again, we need 14.4. So 14.4 will be here, then 16.3 somewhat here. At R we need 17.7, then S again we need 16.3, and P again we need 14.4. So when we complete this one cycle, the variation of the force, so this will be a freehand graph which shows how the force will vary as this object is moving along the circular path. Is it clear? That when object is moving in a circular path, the vertical plane, the variation of the force. So at this point, it will experience the maximum force at P. The resultant force is same, but the tension will be minimum as the weight is acting downward. That contribute to centripetal force. Here, the tension will be greater. Resultant is all the position. The resultant is same, but the value of the tension is changing. So at point P, because the weight is contributing to the centripetal force, so the tension is 14.4. At this point, the weight is not affecting the centripetal force, so it is 16.3. But at point R, the weight is opposite to the tension, so tension should be higher. It is about 17.7. So this is how the tension vary along the circular path. In question 12, a steam engine can have their speeds controlled by a device shown in the photograph. A simplified diagram of a device is shown on the right hand side. The two steel balls, each of the mass m, can move apart at an angle at the end of a lever that are freely pivoted. As a vertical shaft is rotating, the two steel ball moves apart so that the angle between the lever and the vertical is theta. This action is linked to the valve that reduces the flow of the steam. So basically, what happened when the shaft rotate, the masses move away, and it changes the speed at which the steam is leaving the engine. Complete a free body force diagram to show the forces acting on one of the steel balls. So one of the steel ball, the weight is acting downward, and whenever object is pivoted, or there will be a tension in the spring, or the force will be there acting. So free body force diagram represent the forces which are acting on the object. So there will be a weight, and the tension. The shaft rotates at 65 revolution per minute. We have to calculate the theta. 65 revolution per minute, so that is omega. But this we have to convert into radian per second. So how to convert revolution into radian? We will multiply by 2 pi. And then because it is the omega is equals to the angular displacement divided by time. But this theta is different from this. Theta is the angular velocity, angular displacement. But this theta is not the angular displacement. It is the angle, the vertical angle between the pivot and the object. So we'll work out omega here. How we work out omega? So omega is equals to 2 pi into 62 divided by time is in minute. We convert into second. We normally multiply minute to second. We multiply by 60. But why here it is divided? Because the theta is radian per second. So if time is in minutes, we have to convert denominator into second. That's why it is divided by 60. So this will give us the value of the omega. Now, when object is moving in a circular path, the centripetal force is equals to mv square over r, or mr omega square. So we have the m, the mass of the ball. What about the radius? How to work out the radius? Radius, we need a radius of a circular path. So how to work out the radius of a circular path? Like this is r. So it is making a right angle triangle. The total, this length is L, this angle is theta. So the component which is with an angle, that is cosine theta, and against the angle is sine theta. So what it will be R? R will be equal to L sine theta, because this is L, theta is there, this will be L cosine theta, L sine theta. So value of the R, the radius is equals to L sine theta. The formula for centripetal force is mr omega square. M is the mass, which is 5.1. What about R? It is equals to L sine theta. And what about omega? Omega is equals to 62 multiplied by 2 pi divided by 60. Still, we will have theta is unknown, L is known, theta is unknown. So we'll not able to solve. Now, what about the centripetal force? How to work out the centripetal force here in this example? So weight of this ball is acting downward. And if we continue this line, the angle, these two angles will be same. As we continue the line, this angle will be theta. The centripetal force is the one which is acting toward the center. So there will be a component of the weight which is responsible for centripetal force. So this is weight, W is there, the component of the weight which is with an angle. So that is W cos theta. And this will be equal to W, the component of the weight which is against the angle, that is W sine theta. So this will be W sine theta. So W sine theta is responsible for centripetal force, or in place of centripetal force, we can say W sine theta. So FC, the centripetal force, is equals to W sine theta. And what about theta? Theta is this angle. So first, because it's a 6-mark question, so one is the 1 mark when you work out the value for omega, and then the centripetal force will be equal to mr omega square, and we know the centripetal force will be equal to the component of the weight, that is equals to W sine theta, and here it's equals to mr omega square, and W is equals to mg. So I can say mg is equals to mr omega square. M will cancel with m. So g sine theta is equals to r omega square, and sine theta is equals to r omega square divided by g. We have the value of the r, which we already worked out. And remember, don't forget to convert the unit. It is in millimeter, so it will be 0.27 meters because we divide by 1000. So r is equals to L sine theta. We get the value, L is there. So we'll work out theta is equals to, so we'll get the value for r. Or you can also use, because the formula is F is equals to mr omega square or mv square over r. So using the value, the component, we have the value of r, we have omega and g. We substitute the values to work out the angle theta here. Like substitute this value to work out the value of r. So you have to substitute the values. The formulas are same. So what we did, it is moving in a circular path. This is how it will rotate. So the force which is directed towards the center, that is a centripetal force, Fc. And that centripetal force is balancing with a component of the weight, like W is there, which is acting downward. So there will be two components of the weight, the one which is with an angle, that is W cos theta, and against the angle will be W sin theta. So the centripetal force is actually equals to W sin theta. So after working out the centripetal force, and the centripetal force is equals to mr omega square, or centripetal force is also, we have the formula mv square over r. So any one of them you can use, where r is the radius of this circular part, which is equals to L sine theta. So you just have to substitute the values and get the final answer. The next question is a derivation of the centripetal acceleration, and you have to learn this derivation as this question is repeated. An object travels with a speed v around a circular path. So there is an object which is moving in a circular path, having a radius r and speed v. Speed is not changing, velocity changing as it is changing a direction. The diagram shows the two positions A and B of the path. The acceleration of an object is A, and we have to derive a formula that acceleration is v square over r. You should include a vector diagram. So what is acceleration? Acceleration is actually change in the velocity divided by time interval. That's called acceleration. So the vector diagram for this question, like here the velocity at this position, the velocity speed is same, but the velocity will be different as the direction is changing. Here velocity is VA, the other one is velocity VB. So if I want to do a vector addition, first I will draw VA. But I need a change in the velocity. This is VA and the other one is VB. The second vector, that's equal to VB. But what is the meaning of change in velocity? As we need for acceleration, we need change in velocity over time. So change in velocity is equals to final minus initial. So it is VB minus VA. So what I need VB, then in vector addition, actually I need VB plus and then minus VA. That will give us the change in velocity. So first I need VB. So I will draw VB first. Then I need minus VA. What is minus VA? If VA is in this direction, minus VA will be, because VA is toward from left to right, the minus VA will be opposite. So this will be minus VA. This one is VB. And what about the resultant? The resultant is from tail of the first to the head of the last. That will give us the change in velocity, or we can also say delta V. So this is a vector diagram for the change in the velocity, VB minus VA. And the angle between them, angle between VA and VB example, that is equals to theta. Now, if I need this angle, as it is making a right angle and the theta is very small, so we have the formula V equals R omega. So V is equals to R omega. That is the formula which relates the speed, radius, and the angular speed. So as V is equals to R omega is there. And what about omega? Omega is equals to theta, the change in angle divided by time. So in place of omega, we can write change in angle, or delta theta divided by t. So V is equals to R delta theta divided by t is there. So this is one of the formula, or from this formula I can also say theta is equals to omega into t. So in place of theta we can write omega into t. So omega multiplied by t is equals to theta. And now when we try to work out the relation here between the angle and the change in the velocity, like this was a change in velocity, Vb minus Va. This, the magnitude of the velocity, the vector diagram according to velocity is changing because there is a change in direction. But the magnitude is not changing. So this velocity, I can say this is V. This velocity is also V. If I use a trigonometric ratio, a right angle triangle, for example, I use sine theta or cosine theta. So sine theta is equals to perpendicular divided by base. So it will be change in velocity divided by any of them, for example, VA or VB. But VA and VB are same as V, so theta is equals to delta V divided by V. And when theta is very small, normally this theta is in radian, which is a very small. So when theta is very small, in that case, sine theta and theta have approximately the same value. So in place of sine theta, this is only the condition that sine theta is approximately equal to theta when theta is very small. So we can say that theta is equals to delta V divided by V. So in place of theta, I can also write delta V divided by V. So the part, like now this is just like sorting out the formulas, now deriving a relation here as we want to. So we work out by drawing a vector diagram, we work out that delta theta over V, or change in velocity over V, is approximately equal to theta, as a theta is very small. So delta V over V is equals to theta. And or I can say, if I cross multiply, so V is equals to delta V divided by theta. And we know V is equals to R omega. And what about omega? Omega is equals to R, the radius, and V is equals to R omega. So R is the radius and omega is change in angle, or the angle. You can say theta divided by time interval. So in place of V, or the value of the theta is equals to delta V over V. So in place of this, I can write, because what we need the value of the theta. So theta is equals to delta V over V, or theta is also equal to, as omega is equals to theta divided by t. So theta is omega into t is also equal to theta. So if we compare the two values, like one side we have delta V over V, and the other side we have omega into t. And omega itself, if we simplify this, like t is multiplied, other side will be divided, and v is divided, other side will be multiplied. So delta V over t is equals to V omega. So what is delta V over t? That is equals to the change in velocity over time, or we can say acceleration. So acceleration is there, is equals to V omega. And we know V is equals to, or omega is equals to V divided by R. Like here V is equals to R omega, so omega is equals to V divided by R. So in place of omega, we can write V divided by R. So A will be equal to V square divided by R. So that shows that acceleration is equals to the centripetal acceleration is v square divided by r. So 1 mark, 2 marks are there for vector diagram, and for vector diagram, after drawing the vector diagram, we work out that the sine theta is perpendicular divided by hypotenuse, so that is delta v over v. But because theta is very small, so theta is very small, sine theta and theta have the same value, so theta is delta v over v. And the other formula, omega is theta divided by t, so theta is equals to omega t. So we have these two formulas, and from these two formulas we work out that delta v over v is equals to omega t, or delta v over t is equals to a and equals to v omega, and v omega is equals to v over r. So we substitute, we'll get a equals v square over r. So this is a derivation of centripetal acceleration, like the formula for centripetal acceleration. Is it clear? This derivation, it is important for exam point of view as well. In part B, the photograph shows a toy with a small airplane and suspended from canopy by wires. As the airplane rotates, the airplane rise and following a circular path, as you can see. At a particular speed, it is making the following circular path a diameter. The circular path is having a diameter, so like this whole distance is given, which is the diameter equals to 10.8. So radius will be equal to 5.4 centimeter. And the angle which it is making, that is 19 degrees from the vertical. We have to complete a free body force diagram for one of the airplane. It's the similar question as the previous one. So weight is acting downward. When we draw the free body force diagram, the weight will act downward. And if I'm using the left hand side plane, then the tension will act towards the point of contact. If I'm talking about the right hand side plane, then I should draw this pattern. And you have to label both arrows, weight and tension. Show that at this speed, the time for an airplane to make 4 complete rotations is about 3 seconds. Mass of the airplane is 5.2, so you have to convert into gram. It will be 5.2 into 10 to the power minus 3 kilogram will be there. So again, the weight is acting downward. There is a tension in the spring. And it is making angle 19 degree to the vertical. This was 19. Weight is acting downward, so there will be a centripetal force. This tension will have 2 components. The one which is with an angle, it will be T cos theta. So this will be equal to T cos 19. And the one which is against the angle, that is equals to T sin 19. So T sin 19 is directed towards the center, so it is responsible for centripetal force. So FC, centripetal force, is T sin 19. And T cos 19 is acting upward, weight is acting downward. So they both are balancing with each other. So I can say, we can write the 2 equations. We can say that T cos 19, which is acting upward, balances with the weight, and T sin 19 is actually the centripetal force. So then we'll first get the tension from the first formula. We know T cos 19 is equals to, so we'll use the first formula, that it will be T cos 19 equal to mg. The mass is 5.2 into 10 to the power minus 3. Because in the question it is in gram, we have to convert into kilogram, and the gravity is 9.81. So using this, we'll work out the tension, that is 0.054 Newton. That is the tension in the, after working out the tension, we have the tension. So we can find the centripetal force, Fc, and so T sine 90 is equals to centripetal force. And what is centripetal force? It is m r omega square or mv square over r. So we have tension, we have sine 90, we have mass, we have the radius as well. The half of diameter will be the radius. So this will give us the value of omega. And we'll just substitute, we'll get the value for omega after taking a root. That will be 7.9 radian per second. Now, in the question, we need how much time it will take for 4 complete revolutions. After getting omega, omega is equals to 7.9 for complete rotations. So after getting the value of omega, omega is equals to angular displacement. So in 4 complete revolution, angular displacement will be 4 into 2 pi. Because 1 complete rotation is 2 pi, 4 complete rotation, 4 into 2 pi divided by time, and we already have the omega, which is 7.9 radians. So this is 7.9. So time it will take for 4 complete rotation, that is 4 into 2 pi divided by 7.9. This will give us 3.2 seconds. So it will take about 3.2 seconds to complete its 4 revolutions or 4 rotations. If it was for 1, then it will be omega equal to 2 pi divided by t. Student A suggests that if the radius of will increase the rotation and it is rotating at the same speed, the wire supporting the aircraft could be vertical. Student B suggests the wire would be at an angle greater than 90 to the vertical. Either explain whether either of a student is correct. So vertical, and what happened if, for example, if vertical, the horizontal component will be 0. As it is rotating, like in this manner, there is no horizontal component.